Hi everyone, and welcome to Soak It Up, Carbon Sequestering Sites. The learning objectives for the session are shown here, and we'll be following up with a survey and with more information on how to receive credit from AIA. We'll collect questions submitted to the Q&A box throughout the session, and if we aren't able to get to some of the questions, we'll do our best to answer them in writing and share on the website later. Now it's my pleasure to introduce the speakers for this session, Pamela Conrad and Martin O'Day. Pamela Conrad is a principal at CMG Landscape Architecture and leads a global research initiative she founded called Climate-Positive Design, which empowers designers of the built environment to reduce carbon emissions and increase sequestration through the use of free online guidance and resources, including the Landscape Carbon Calculator app called the Pathfinder, which we'll be demoing throughout the day. Today, recognizing the critical importance and power of intentional landscape design and site development to sequester carbon, Pamela is in conversation with Martin O'Day. Martin is an award-winning landscape architect, accomplished artist, and designer with over 30 years of experience. He's Associate Director at Claston Associates Sydney office. He was the principal author of the Australian Institute of Landscape Architects 2020 Climate Positive Design Position Statement and is the chairman of AILA's Climate Positive Design Taskforce. Given their dedicated leadership and remarkable alignment on the climate targets and path to carbon sequestering landscapes, I'm really excited for this conversation, and I will give the screen now to Pamela.
Hi everyone, I'm Pamela Conrad, and thanks Natasha for the kind introduction. So today, as she mentioned, we're going to be talking about soaking up greenhouse gases in the landscape, and joining me today is my good Australian friend Martin O'Day. Martin's going to share a little bit about himself with us and how he's leading a climate positive initiative at the Australian Institute of Landscape Architects. But I believe that the main reason that we're here today together is because both of us see the value and potential to improve quality of life, increase biodiversity, and contribute large-scale natural climate change and carbon sequestration strategies through the landscape. And we're going to do our best today to briefly just introduce ourselves and the work that we're doing and how we're taking action through climate positive design for about 10 minutes each, and then save time to hopefully answer all of your questions that you might have, which can be submitted directly to Natasha, and then she'll distribute it to us directly at the end. But to get started first, we would like to get to know you a little bit. So would you please take a moment to answer the two questions that pop up on your screen? And Natasha, please let us know the survey findings after we do our introductions.
Thank you, everyone. Our responses are coming in, so I'll leave the poll open for another minute.
Okay. And while you're doing that, I will go ahead and introduce myself and a little bit about my work, and then we'll hear the survey results and hear a little bit about Martin. So I'm going to go pretty fast, actually, and kind of cut to the chase of who I am, what I'm up to, and why this matters. And I'm starting from a point of beginning for me, and because this is me, and this is why I care about climate change. As I grew up on a farm in rural Midwest United States, and I grew up really closely with the land, and a father that believed that we should be stewards of the land, protecting it and what it's given to us. And it was because of that deep connection that has caused me to become an advocate for climate action and climate strategies, and it's what made me want to become a landscape architect. And I went in from very humble beginnings to the big city in San Francisco, California. I was very fortunate to be a first-generation college graduate, and this is the wonderful office that when we're all working together, I get to spend time in and work with a bunch of talented landscape architects and urban designers that care very much about the work that we do every day in our built environment. Much of the work that I've done over the past 6 years or so has been focused on some large-scale urban planning projects that have put climate adaptation first. In terms of Treasure Island, it's about 500-acre island, partially man-made in the middle of San Francisco Bay, and it led the first planning guidance for sea level rise adaptation in the entire Bay Area region. Another project that I've worked on for the last several years is called the San Francisco Waterfront Resilience Program, and it stretches for about 7.5 miles along San Francisco's waterfront, and is planning for how we can have an adaptive future to sea level rise and also be protected from future earthquakes. But it's been through this work that I have started to ask myself, what is the impact of the work that we're doing through these projects? And we know from Architecture 2030 that the urban built environment is responsible for about 75% of global greenhouse gas emissions. Now, those emissions are leading to what we're seeing every day now, including rising temperatures, reduced air quality, fires, and sea level rise. And actually, about half of those emissions come from outside the building, surprisingly enough. And as an urban designer, landscape architect, I have started to ask myself, how can we reduce operational emissions? How can we decrease the embodied carbon that's going into the materials and the places we design? And how can we increase carbon sequestration? But the challenge has been that there hasn't been a good way for us to measure these impacts. So through landscapes, we have the opportunity through the natural carbon cycle to take greenhouse gases out of the atmosphere through photosynthesis and sink those into the ground through the trees and plants that are within landscapes, taking in primarily human emissions that we're taking up fossil carbon and burning it and releasing it up into the atmosphere. And it's what's causing climate change. Now, there are so many things that we can do to my screen here. There are so many things that we can do to reduce carbon footprints in the built environment. We know that designing landscapes to be, and urban design places to be more bikeable, more walkable. We can use local and reclaimed materials. We can use cement substitutions in our concrete, minimize soil disturbance, and ensure that the carbon that has been sequestered can stay in the soil by using amendments like biochar. We can also increase carbon sequestration through planting as much as we possibly can on sites, whether it's green roofs or vertical gardens, to use super sequesters like bamboo, maximizing the amount that we're able to sequester through plants by using woody plants like shrubs and instead of lawn areas, and then protecting and restoring our natural ecosystems like forests, coastal wetlands, and seagrasses and mangroves. Now, I started wondering in my projects, what was the impact that that was happening through the design and building of constructed landscapes. And frankly, what I found is that there wasn't a good way for me to measure this as a landscape architect. So I started with a very crude version about 4 years ago to understand the emissions and the carbon sequestration. In this simple project, this is a few acres. The red number shows the amount of CO2 emitted from this project, and the green number shows the amount sequestered as sort of a business as usual. And this being very sustainably minded, thinking that I couldn't imagine, there's not much that I could have done better. And from a sustainability standpoint, it still was taking 15 years for this project to offset itself. And then when I started to see the numbers in front of me, I realized that once I started to understand those emissions, understand this carbon sequestration, that there was an opportunity to reduce the amount that was emitted and increase the amount that was sequestered by, increase by 600 metric tons, reduce that by 200 metric tons. And instead of the project taking, as it was 15 years to offset, I had the opportunity for that project to offset itself in 5 years. And that could be accomplished by using materials with lower embodied carbon, like crushed stone paving instead of asphalt, planting a few more trees, converting some of the lawn areas to shrubs, and using electric maintenance equipment. And essentially, there was really no major change to the project. Still was high quality, still functioned the same way. It was just essentially greener at the end of the day, with a much better carbon impact. Looking at another site a little bit more urban, and we know that places that are urban that have specific programming, it is harder to accomplish low carbon footprint. This half-acre closet would take almost 200 years to offset the carbon footprint from it. But again, having that information on hand as a design tool and understanding the impacts, again, was able to take that project from, instead of taking 200 years to offset it, it take 20 years. Again, simple strategies, reducing the amount of paving, increasing planting, adding some trees, using more woody plant material, and just being mindful about the embodied carbon that is in the materials by using cement substitutions. It was, again, a pretty significant difference to the carbon impact and the overall years it would take to offset it, again, without significantly reducing the quality of the design. And so I started to think, well, if I were to do this, it's not going to make that big of a difference. But if every landscape architect in the world were able to do this, and all of our million projects that we'll probably build over the next 30 years, we could make a big difference. If we start to see our business as usual has us at likely emitting more carbon than we're sequestering, that's the graph on the left. But if we were to make just those simple changes comparable to what are in those case studies, we could be on the graph on the right, where we are sequestering more carbon than we're emitting, and that we have an opportunity collectively around the world to be taking upwards of a gigaton of CO2 out of the atmosphere over the next 30 years. And because of this information that I learned through these studies, I launched last year the Climate Positive Design Challenge. It was through those case studies that informed setting targets for our projects in terms of the years to offset. And more importantly, offsetting our projects as soon as possible so we could then become climate positive, taking more greenhouse gases out of the atmosphere than emitted and becoming climate positive. And so for projects that are inherently greener, like parks, gardens, campuses, mixed use, setting the targets for those projects to be 5 years to offset, to be positive, and more urban projects, setting the target for those to be 20 years. And how designers or planners can meet the goals of the challenge is by using the web-based app that I developed called the Pathfinder, which you're able to watch demos of in this conference. And the Pathfinder guides designers to reduce carbon footprints and increase carbon sequestration in their projects. The data for the embodied carbon and materials comes from the Athena Impact Estimator, and the carbon sequestration data comes primarily from the U.S. Forest Service. This is also third-party verified by the environmental consulting firm Atelier 10, and it's largely supported by my firm CMG. So in going through the design of this project, I had some good input for some colleagues from the Landscape Architecture Fellowship, and they helped me to realize that to make this usable in our day-to-day work, that it should be easy, integrate into our workflow, and provide feedback to know that designers are making a difference in the choices that they're making. It's pretty simple. You essentially, as the designer, provide the quantities of materials, plants, and maintenance operations that you have in your project. And then you received instant carbon feedback that's operating live. In terms of red is your emissions, green is your sequestration, and then it gives you a live years to positive score as you're entering data. And so the overall goal for the initiative is to improve the carbon impact of the built environment through taking collective action. And I believe that it takes more leaders to empower the designers of the world to take this action, that we need to work together and also educate ourselves in the future generation. Within the first 6 months of the initiative, close to 100 countries were reached out of about 195 in the world. Within that time frame, there are close to 900 projects logged, over 600 contributors from 500 companies. And those projects were estimating planting about 500,000 trees, which is about the equivalent to taking around 300,000 cars off the road in 10 years, or close to 1 million cars off the road in 30 years. So without any expectations, essentially at the gate of how this was going to work, it seemed to have pretty good response in the first 6 months. And what we're seeing is that projects are improving their carbon footprints and carbon impacts from looking at the first 45 days to the first 6 months. we're seeing a decrease in the years to positive across the board for all types of projects, and for the first time understanding how much carbon we're emitting and how much carbon we're sequestering on an area basis, and then how those relate to each other. And then I'm going to wrap it up here quickly and turn it over to Martin, but I'm wanting to leave this with a bit of a provocation for us to think about. Now that I've showed you an example of what one person can do, starting to think about one simple idea that can be scaled up to potentially make a big difference. Now, the 1 Trillion Trees study, if you're not familiar with it, is a brilliant study that comes out from a Swiss institute, looking at how many trees the Earth can accommodate, coming up with a number, 1 million trees. And I think it's a wonderful study. But there was one thing that bothered it about me, and that was the fact that urban areas were excluded from this number. And I wasn't quite sure at first why this didn't sit well with me. And the reason that it didn't is because I stepped outside and my city looked like this. And I started to think, well, maybe it's not the best place for trees, but I think it sure would be a lot better if there were more trees for the quality of life, for having more nature in your city, for having cleaner air, and why not also sequester some carbon while you're at it. And so I think this is an opportunity for us to think beyond site designs, to start thinking about the potential of urban forestry as another toggle that we can impact in terms of taking greenhouse gases out of the atmosphere. And I would just like to add that most of the world's population lives in a very small area in the world, and we are, at least in the US, woefully under the recommended urban forestry canopy cover. And I think that just to get up to the recommended percentage, about 40% canopy coverage, we could be planting another 150 million trees. And we can start to look at the impact in carbon sequestration for those trees, just to get us to the minimum of trees that we should be planting in our cities and from an urban forestry standpoint. And so, that's a couple more gigatons of CO2 that we can help contribute to the overall solution. And then I would challenge us to think about why not scale that up and push a little bit further, looking at some of the initiatives of a forest and tiny forest and microforest, and adding maybe 20 more trees per acre, and push those numbers up to sequestering even more carbon, maybe doubling those numbers in terms of sequestration, to have an even greater impact. And so I think that that's the challenge for us as landscape architects or urban designers to ask ourselves, can we continue to push the boundaries of traditional design and design for climate action? And if you are interested in any of the resources that I shared, they're all available on the website, climatepositivedesign.com, including the Pathfinder app. And I'm going to turn it over to Martin. But first, it looks like we have some poll results in. So this is brilliant. Fantastic. I think this is the first session where we have had a whole bunch of landscape architects. So fantastic. Are you all seeing these survey results as well, Martin and Natasha?
Yeah, I think everyone can see these poll results, and it's really heartening to see so many landscape architects and so many people who can take your message and your tools.
That's great. That's fantastic. So hopefully some of what I was talking about makes sense to all of you, and hopefully what Martin is going to share will also be impactful to your work. So I will go ahead and turn it over to Martin, and then hopefully we'll leave some time for discussion and Q&A. Please be sure to note those down so we can have a conversation.
Yeah, please enter your questions in the Q&A box.
Hi, everybody. Can you see that?
Yes.
Great. Thanks, Pamela. That was a great little prezzo, and I think a lot of interesting thoughts for people in terms of long-term options for what we should be doing. So I'd like to start by acknowledging the traditional owners of the land on which I'm presenting from today. That's the Gadigal people of the Eora Nation, and I pay my respects to the elders past, present and emerging, and extend that respect to any Aboriginal and Torres Strait Islander peoples present on this webinar today. So, as part of the Australian Institute of Landscape Architects, I've been wondering, how do we get to a carbon neutral solution? So about a year ago, I began a journey with the Institute in terms of setting up a position statement, and that's ended up being what we've termed our climate positive design position statement. And really that's about how our projects can sequester more greenhouse gases than they actually emit. And to make it simple, we've chosen 3 very simple ideas that landscape architects can use. And the first one is really to understand the environmental and carbon impacts of what we do through evidence-based design and software like the Pathfinder that Pamela has helped develop. Secondly, it's to manage and mitigate those through good planning and design. And lastly, to advocate and educate. So how do we talk to our clients, our colleagues, our stakeholders, and also government? So we have a whole range of where our emissions come from, and unlike buildings, a bulk of our emissions actually come in the construction stage and not operationally. So when we fell out any trees, we lose that sequestered CO2 and foregone CO2. Cement, concrete, steel, galvanized steel and aluminium are all big parts of our footprint and have a huge amounts of embodied CO2. One of the interesting things that's come out of the app has been that nitrous oxide emissions are actually quite high. And given that they've got a very high global warming potential, they do make a difference. And lastly, two-stroke maintenance equipment is very, very polluting. So one of the benefits of as being a landscape architect is the opportunity to plant trees, and trees really are the world's simplest carbon capture and storage machines. But starting early really does matter, because they do take time to grow. So if this is a series of images of spotted gums at 1 year, they're going to maybe have 8 kilos by 5 years in a good growing condition. This is Barangaroo. They're going to be 230 kilos, maybe a bit longer, 15 years time, we're getting 1,800 kilos. And by the time we've got quite big trunk diameters, we're getting to a point where we've got 12,000 kilograms, 12 tons of CO2 maybe sequestered by 2050. So this is a diagram of how that sequestration might work. This little sketch here sort of shows different sort of profiles depending on where trees might be planted and species. But broadly, we're going to start with our small tree, and as it gets bigger, it's going to get to a point where it reaches its sort of maximum canopy size. And that's important because that's sort of the maximum sequestration power that's going to have in terms of carbon coming through the leaves and being able to be converted into cellulose. That tree will eventually keep growing, depending on species, but there's going to be a point where it'll start to get to an age where it's going to die and let branches start to fall off, and the actual carbon sequestration drops off. But at the same time, carbon soil is building up. In a forest situation, when this tree dies, it goes back to sort of the level of the carbon. In a sort of forest situation where there's more trees, obviously we're going to plateau out. But what we're trying to capture is this growth phase here in terms of drawing down CO2. So this graph here represents the graph from 1958 at the Mauna Loa Observatory in Hawaii, and it's showing the relentless rise of CO2. But we see this little drop every time, and that was always found very interesting. And in fact, it's the planet's trees breathing and how they're drawing in CO2. So every year the trees sort of pull down about 7 parts a million, which is a huge amount of CO2, but we're overpowering it every year, and by another 2.2 parts a million. So it's on this relentless climb. So this is a photograph taken by NASA earlier this year at the peak of sort of winter, and you can see the foliage cover is quite low in the northern hemisphere when everything's covered by snow, and all the deciduous trees are out of leaf. And then as it bursts back into life in spring, this is what drives this massive drawdown of CO2 on the planet. So how many trees might we need? Pamela mentioned the 1 trillion tree program. And if we look at, say, what that might mean out of the 3.1 trillion trees on the planet, if we take, say, our share of global emissions, say Australia, for example, would need to plant 11 billion trees covering 60 million hectares. or 500 trees per person. And that's planting trees at 1 million a day to get to 2050. So we have a hell of a lot of trees that we need to plant, and we need to really make a start immediately. So if we look at a conceptual project here, starting this year, there's some design and planning emissions from driving and maybe flying to the site if you actually can fly. Then the construction period is going to embed quite a lot of carbon in all that concrete and steel and other elements that are in our built environment. And then there's operational emissions from management and maintenance and so forth. And they're all cumulative. They all stack on top of each other. And you can see that the pink represents the cumulative carbon. And here's our trees trying to pull that down. But this is unsustainable. We're just simply outpacing what we can possibly do. So the critical thing really is that we really have to reduce our embodied energy first. Reduce the embodied carbon by bringing that construction embodiment down, and also the operational level as low as we can, so we can get to a point, hopefully about 2030, where our trees can start to overtake that actual carbon that's in a project and actually start to make a difference on the planet as well. So we move into climate positive territory. And if you want to look at how it might be per element, say 10 square meters of concrete, to be positive by 2030 if it was built today, we're looking at maybe 3 trees to offset that. Our lovely concrete seat walls, another 12 trees, 10 square meters of an office building, 120 trees. If we start that 5 years' time, in 2025, and still want to hit 2030, it's not double the amount of trees, it's triple, because we're trying to get that carbon sequestered with a much smaller tree. So we're going to 11 trees, 42, and then 420 trees. And if we look at a building, this is a fictional building that has operation emissions. And it's a large building, and many large buildings do have big footprints. So say it's built to code, might generate 3 million kilos a year. At a 5-star rating even, it's still generating quite a bit of carbon, 2.5 million kilos. And we'd need a forest about the size of Centennial Park and Queen's Park at least, just to break even, keep that neutral, 32,000 trees. So bringing our operational emissions down from a built environment point of view is also essential, and getting to zero carbon. So there are the co-benefits of trees, and there's obviously visual quality, pedestrian comfort and amenity, stormwater interception, health and wellbeing benefits. We've found that property values are increased by proximity to trees and parks. There's air quality improvements. We're using less energy to heat buildings when they're shaded by trees, and also cool cities. So the Asia Pacific region and our tropical cities are going to be heavily impacted by increased temperature and humidity. And this is RCP 8.5, which is the worst possible do-nothing approach, where we're looking at very high numbers of deadly days of heat and humidity, where it's just beyond human physiology to survive outside. We don't want to go there. But what we're hoping for is that we're looking at how urban canopy cover can help with a city's urban heat island environment. And 40%, which is a cover also mentioned in Pamela's talk, is really a minimum target we should be trying to hit. And the research that we carried out in Darwin, which you can see here, is that trees provided much better shade outcomes to the built environment, particularly streetscapes, than things like awnings. And here's some infrared photography that shows that out in the open, the pavements are around the 60 degrees Celsius mark, but under cover in Darwin it's 38 degrees, and in Melbourne this picture here is showing that it's almost half. It's 34 degrees Celsius on the pavement. So that's making a huge difference to the amount of heat that's being absorbed by pavements that would otherwise get re-radiated out. So a recent project in Darwin, we were working on a new entry road into the city, and we knew it was going to have very large pavements. So what we were hoping to try and achieve is a very big shade coverage for that. So we planned a huge continuous soil trench, which has 50 cubic meters of soil per tree. And that extends under the pavements on either side by using a structural system. And here we are 6 months after planting, and this is Salmonia saman, rain tree. And you can see they're they're doing quite well at the moment. But this is what we're aiming for, a 30-meter diameter tree with enormous shade footprint for the road and the pedestrians and the cycleways that we've got beside the road. And there's all these co-benefits that's going to generate. And one of the things we've been looking at is how do we water these trees in a dry tropic environment. And we've been looking at using stormwater harvesting, obviously, but also using air conditioning condensate from buildings to feed the bottom layers of these planting beds to sustain them through the dry season. So the top 5 things you can do as a landscape architect. First of all, understand your carbon footprint. So use an app like the Pathfinder app or a similar tool to understand what your impact really is. Test out alternatives for those projects. Learn about low carbon alternatives for those. Then, like all good risk mitigation strategies, the key thing to do is to reduce the extent of high carbon elements within your project. So we need to design down and out those high elements such as concrete paving, reducing those hard paved surfaces with soft surfaces where possible, designing out steel and reducing intensively maintained lawn, and maximising our tree protection on site. Where we can't design those out, the next thing we need to do is specify those sort of low carbon substitutes. So things like polymer concrete, green steel, replacing steel with other materials, and looking at how we specify electric maintenance equipment, biodynamic fertilizers. So there's quite a lot to think about in here in terms of what we say, but if we don't specify these things, the built environment industry won't be providing them. So we need to ask that question. Then we need to plant as many trees as possible. How can we squeeze in a little carbon corner into our project? So retaining existing trees, but prioritizing high quality ground preparation over stock size. So how do we get the biggest, largest root volume we can possibly get, maximizing that with passive irrigation and other clever techniques to really make these trees grow in the long term. It's no good having a tree that looks great that's in 1 cubic meters of soil. It's got to be as big as it possibly can. And then lastly, how do we start that conversation with our clients and our colleagues? So that is sort of looking at how we might raise awareness of a project's carbon footprint, what we might do to consider biodiverse offsets where we can't possibly sequester everything off site. And that's about looking at how can we start to restore the built environment and the landscape around us by funding restoration. And that's not to be used as a crutch, but we do actually have a big footprint we're going to need to start to draw down. How do we engage with manufacturers on environmental product disclosures? And lastly, how do we push for legislation and code improvements so that we've got real change that's required at the actual construction stage, and we're actually requiring contractors to do that. So thank you, and I think we'll be over to some questions now. I might stop sharing my screen.
Thank you both. Yes, we have a couple questions in the inbox, and the first is, what is the best tree to plant for carbon sequestration?
Pamela, do you want to have a quick hit at that one?
Sure. People ask this question a lot, thinking that it's going to be one species or another, but the reality is that it varies based on whatever region your project is in. So you want to plant the tree that is going to get the biggest and live the longest and require the fewest resources. Fastest growing is also wonderful too. Essentially, carbon there's a relationship to carbon sequestration and biomass. And so that's what you need to be targeting to sequester the most carbon, is dependent on your region, what tree is gonna hit those 3 different factors.
Yeah, I'd agree with that. I think, and that's going to be something that's important at a local level, what you're going to need to choose, and choose the tree that is best suits you.
Mm-hmm. So what happens to the carbon stored in street trees at the end of their life?
That's a very interesting question, and it begs the question of how we actually think about managing those trees across their lifetime, and how someone like a council or an owner and manager might start to consider them more as a carbon forest. So I think that's a discussion we need to start to have with the long-term owners and managers, so that we could see how could these trees, if say in a storm it blows down, or at the end when it's sort of getting to the point where it has to be felled, that those trees could then be managed in a way that becomes something that's used in a timber product somewhere and locks that timber away for another 50 years.
Yeah, I'll add to that too that you know, there's definitely more research that needs to be done about soil sequestration. I think though the general consensus is there's, you know, maybe maximum about 20% of the carbon that the tree intakes is actually you know, sinks into the soil. And so after you cut down the tree, that there's still some that remains in the soil that again varies based on the soil quality. And then as Martin was stating, you know, you're cutting down the tree, you can turn that to a lumber product. And so essentially, you know, your wood table, the carbon remains in that wood table for as long as the, you know, the table essentially exists without decomposing. And so you can also do that in terms of, you know, if you have to cut down a tree on the site, you can turn it into a site furnishing, which as long as, you know, it is going to weather and decay to some degree and start to release some of that carbon back up to the atmosphere. But as long as it's kind of staying in, you know, a sort of whole, you know, status that that carbon is stored within it. You can also partner up with biochar facilities as well. So if you have to cut down a large amount of trees, you can send them to biochar facilities, and essentially they heat up the wood. Very high temperatures without the presence of oxygen, and it converts the, you know, the wood essentially into this fertilizer, this carbon-rich fertilizer amendment that you can put back into your soils, which improves soil quality, because carbon is essentially a binder that attracts all kinds of other good material, essentially soil amendments that benefit the overall health of the soil.
Mm-hmm. Thank you for that. I think we have time for one or two more questions. So we have one about how, directed for Martin, how have efforts to try and get government involved, actively involved, gone?
Thanks, Ben. The look, the AILA is one of the key things that we are going to try and do is engage with the government and engage with at all levels, at state, federal and local government level, to see how we can help drive that story, particularly for the built environment and the use of green infrastructure, and the importance that can have to our built environment. But we do know that there's some fantastic things that are happening. For example, there's a 5 million trees program for Sydney. Melbourne's just launched some new applications that are looking at the green side of the city. So there's some really good things that are happening, but AILA is definitely going to be pushing to get engagement with both at a local, state and a federal level.
Mm-hmm. Thank you so much. And here's one last question for you, Pamela. When using the Pathfinder tool, is there a ballpark, benchmark, or time frame we should be aiming for a project? For instance, putting into a brief for a project? What do you advise is the best process for reaching a meaningful benchmark?
Sure. So you can go to the CarbonPositiveDesign.com website and refer to the challenge tab, and it outlines the targets for projects. And so I think, as I mentioned, that being 5 years to positive for projects that are sort of inherently greener, parks, gardens, campuses, mixed use developments, and then 20 years to positive for more urban projects like plazas and streetscapes. And you know, you can use language from that page. And I think, you know, every time somebody, you know, submits a project, essentially we're adding to our collective knowledge, and so that those targets may evolve over time if we're finding that they're too hard to reach, or if we feel like we're doing a really good job and we need to be pushing ourselves harder. So it is a matter of, this is data that now we have been collecting for a year, but as we continue to add more projects, it'll just only refine what we're able to do collectively. I'll also advise anyone that logs a project is recognized as a contributor on the Climate Positive Design website. And so, you know, you log in your project, you list your company name or your own name, and it should be showing up, you know, pretty much instantly on the contributors page, recognizing that everybody just logging their project is making a contribution to this overall kind of collective action.
Thank you so much. We're out of time, but any questions that we didn't get to, we'll do our best to answer in writing on the website. And there also will be demos of the Pathfinder tool in the break that's just coming up right now, which I would encourage anyone who's interested in trying it out to listen to.
Thank you all very much.
Yeah, thank you very much, everyone. Appreciate that.
Thank you.
Bye-bye.